YouTube audience, this is ScienceMan131313. This is my first video. Hooray! Okay, so in this video I'm going to be talking about a radiation detection project. So, in light of recent events, it might be wise to have a radiation detector. Now there are a couple options you can go with. You can buy the surplus Geiger counter. You can get like a civil defense one or something, but they work alright most of the time. But they are heavy and cost from $60 to $150 if you want to get like one of the surplus lower end ones. So you can go with that, or you can get a dosimeter. This dosimeters work alright, but they don't give you real-time radiation feed. And also, this dosimeter, even though it costs only $6, it is designed for really high amounts of radiation. I mean, incredibly high, like 200 grams. So, the average person hopefully doesn't need to detect that much radiation. You can go with those really nice Geiger counters that cost like $500 that are pocket sized and they do all this fancy stuff and they have an LCD display, but who wants to spend $500 on something that you can make? So this is what this video is on. So this is what I built. It is a miniature Geiger counter, extremely simple, like one of the simplest I've seen, and you'll probably know why. All it is a Geiger tube, a power transformer, a battery, a switch, a resistor, altoids tin, and a high sensitivity earpiece. It is insanely simple and very cheap. Cost me about $20. I bet someone could get it or make it for even cheaper. Who knows? So here's the circuit behind it. We have the AAA battery. We have the power transformer. The power transformer came from a flash camera, a disposable flash camera that I got from Walmart for $3. And then we have the positive end from the transformer going to the Geiger tube. So the Geiger tube is a Russian surplus Geiger tube that is polarized. So you want to make sure that the positive power output from the transformer goes in the positive end of the tube, and vice versa, the negative end goes in the direction of the negative end of the transformer. Alright? The resistor inside here, if you can see that, is optional. You don't need the resistor. I was just experimenting around, seeing what it'd do. It didn't really have much of an effect. So, then you have the tube hooked up to the high sensitivity earpiece, then back into the transformer and back to the battery. You can have a switch going to the power transformer or onto the wire that leads from the battery into the transformer. Like I said, it's amazingly simple. It can be improved. If anyone wants to tell me about how I can improve this, I'd love to hear about it. But this is it so far. And it works great. I mean, I can hear the radiation. I can hear the ticking away when I stick the radiation by it. Unfortunately, the earpiece is kind of quiet, so I bet the camera can't pick it up. But trust me, it works. It detects slightly higher levels of radiation, so about 1 milliröntgen it starts ticking at 1 click per second. Alright, that is all. So please comment and please rate. Any modifications that you can come up with, I'd be very appreciative to know about it. Thank you.